Okay, everyone, Mr. Allen here. Just going to run through these practice questions for the random sampling techniques. I will try to give you time to look at the question, then pause. You can pause the video before I sort of talk through my understanding of the question and reveal the answer. Okay, so which sampling method was used to gather information about the population of Ontario? I'll let you pause here. Looking at these options, it's only really one option that makes sense, multi-stage. And from the picture, they kind of tried to show that with the idea that we started with Ontario, went to Barrhaven, went to an individual street in Barrhaven, and then went to a house as if we'd sort of randomly picked an area, randomly picked a street from that area, randomly picked a house on that street. Simple random definitely didn't make sense because that would be just completely random throughout the entire population of Ontario. We wouldn't have had those step-by-step processes. Voluntary response obviously doesn't make sense because the person was called, and stratified doesn't make sense either. Which sampling method was used to choose the individuals who subscribed to the free at 50 life insurance policy? Well, when I look at this, there doesn't seem to be any kind of a pattern. There doesn't seem to be any kind of a noticeable grouping of the people. And so simple random just means everybody has equal opportunity to possibly get chosen. Systematic means there would be, again, a system to it, every fifth person, every seventh person, something like that. Stratified requires individual groups to exist from the start. And multi-stage means we would just have to sort of make one grouping and then, or one sampling and then go further with it. And so simple random seems to be the only options available here. What proportion of the population is being sampled in the previous question? So time to pause. And we're back. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people out of a possible, what, 50? So 10 out of 20, sorry, 10 out of 50 is 20%. I'm not going to read that whole thing. I'll give you a chance to do so and pause. And we're back. So what method of sampling is being used here? The key is call 555-1111 if you agree with the government's actions. And so it's a voluntary response sampling. And as we know, this is not maybe the best way to go because the people who call will be people who feel who are in agreement or specifically who are not in agreement. And all the people who are somewhat neutral or don't have strong feelings might ignore this. We'll see this a bit more in the bias section that follows. So sampling bias occurs when the sample does not accurately represent the population. Which of the following sampling methods is most susceptible to this form of bias? And pause. And we're back. Stratified means that we would have everybody grouped off and kind of choose a specific number of people from each grouping. So that's definitely not a bias of that sort. Cluster, the idea is that the groups would already be representative of the entire population. And so anybody chosen out of any cluster chosen should be a good reflection of the population. Convenience, of course, is a problem because it means I'm just picking my 5 friends or the people that happen to be hanging out at this location. They might not be in any way a good representation of the whole population. Okay, I'll give you a second to read this one, but essentially we're trying to set up a stratified sample here for the information given. So just pause here and then we'll go through a solution. Okay, so this one requires a little math. There are a couple of different ways I've seen students solve this in the past. There's a nice method and a common method. So essentially what we're looking to do is get the appropriate number of grade 12 students relative to the number of grade 9 students in our sample group. So the best way to go about this, probably the easiest way, is just to set up a ratio here. My grade 12 sample group, when compared to my grade 12 population, should be the same as my grade 9 sample group compared to my grade 9 population. So the number of grade 12s I want compared to the 160 should be in the same ratio or the same fraction, the same proportion as the 30 grade 9 students that I have compared to the 200 that I started with. And then basically I can multiply the 160 across, multiply both sides by 160 technically, and I get the 24 is the appropriate number of grade 12s. The other method people tend to use, and again, perfectly legitimate mathematically, but probably a little bit more work, is they go about finding percentages. And so the grade 9s here are 200 out of 700, so 28.57% of the population. The grade 12s make up about 23% of the population. And so 30 students in grade 9 are equal to 28.57% of the entire sample group. And so the sample group would be 30 divided by the 2.857, or 105 students. And then once we know that there are 105 students in the group, 22.86% of them must be grade 12s. Multiply that by the 105 and we get 24. And so 24 is my answer. So here we're looking for 5% of the grade 9 students to be surveyed. How many students will be chosen? I guess this is all the grade 9 students. So I'll give you a second. I'll pause. So looking this over, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, they're nicely grouped in tens. So I have, looks like 14 groups of 10, so 140 students. I need 5% of that. Well, 10% of the 140 would be the 14, and so 5% would be the 7. Okay, so in this question, we're looking to divide that same group from the last question up. We want to get them into interval groups so that one person from each group can be chosen to get us the 7 students that we want. So without spending much time on this one, I want to be able to pick one person from group 1, one person from group 2, and end up with the same 7 students that I wanted from the last group. Now the question that's maybe a bit more relevant is, how do we divide the group up? How many students go into each interval to ensure I get that 7 students total when I jump from one interval to the next? So again, pause here. And the math is pretty easy. We have 140 students. We need to divide that 140 students into 7 equal-sized groups. So there should be 20 students in each interval or each group. So which student should be chosen next? So again, this is just extending on that same pattern that we just saw. Essentially, we're thinking of our groups as being divided up into groups of 20. And so, oh, sorry, this is I guess that is actually the group of 20. 1, 2, 3, 4, 5, 6, 7 groups of 20. And the question is, if we randomly choose this person to be the first person selected, who will be that next person selected if we're going every 20 students to find our next student? So the question is A, B, C, or D. And again, I'll give you a second to take a look at that. So pause. And basically, because of the way they split it up for us so nicely, this is group 1, this is group 2, and so on. Essentially, we've randomly chosen 1, 2, 3, 4, 5, 6, 7, 8, the 9th person here. Then we jump ahead the 20 students to get the 9th person here. We would then jump ahead another 20 to get the 9th person here, and so on. That's our systematic approach. Go every 20, every 20, every 20. And so student C should be the next student chosen. And that is the end.